Hi guys. Who has heard about Plasma? Please raise your hand. Cool. Who knows what a hashing function is? Okay, the rest can leave the room because you really need to know that. So, let me start. Plasma. So, this will be my whole talk, basically. So, I will talk about this guy, about me, right? Maybe about this guy as well. So, another question. Who thinks me showing this picture increases my credibility in talking here? Please raise your hand. Thank you. Who thinks it doesn't increase my credibility? Okay. The rest is sleeping because that was a binary question and you have to answer one way or the other. So, no, this is not what I'm talking about. Actually, this picture was taken in Paris 2 weeks ago, and there's two guys, Vitalik on here and Carl, and they talked about Prisma Cash for the first time. And I'll be talking about Plasma and about Prisma Cash. But first of all, why do we need Plasma? Well, because we have a scaling problem, right? In a blockchain works the way that everyone needs to verify all the blocks. That creates a capacity problem because the small computers can't keep up. And we basically need to keep the blocks small, so that everyone can verify it stays decentralized, but by that we limit our capacity in doing transactions and also the complexity of transactions. We can't write nice smart contracts that do a lot of stuff because we're limited, and we want to get around that. Here's a bunch of solutions that exist nowadays. I kind of grouped it into 3 pictures. So you can start a new blockchain, of course, or delegated proof of stake blockchain or a proof of authority blockchain, but you always have the problem that's crypto-economic incentives that drive the security of your chain, and if you have a small chain with a few miners, then you're prone to attacks. So we want to build systems that are decentralized and secure. That's why we need to kind of stick with existing big validated systems. And here we are. We have Bitcoin, Ethereum, and so on. Ethereum here on the bottom. We can scale that inside. There is, for example, Casper, which is the proof of stake implementation that's coming soon. There is charting, where we just separate the chain into different parts, but that is not here yet. So what can we do now? We can build second layer scaling solutions. So who of you has used the Lightning Network on Bitcoin? Pretty cool, huh? So that is state channels. That is a logic that is built on top of the chain. It works with the security of the miners of the main chain, but it allows you to do more computation. Plasma is similar to that. It's also built as a second layer solution. And how does it work? So here is how it works. We have Alice and we have Bob, and they send 1 million transactions to each other every day because they enjoy that. But that's way too expensive for the Ethereum chain, so they ask the Plasma operator, this guy here, please take my transactions and kind of, process them. He puts them together, he hashes them in a tree and submits only the hash 32 bytes every couple of blocks to the Ethereum mainnet. And we have a Plasma chain. Cool. Then there is the Ethereum miner, this really tough guy here who mines all that together and persists it on the Ethereum chain. So in detail, actually, it doesn't throw it just on the chain. What he does is he kind of makes numbers for it, like blocks, and then that hash goes to a Plasma contract on the Ethereum blockchain. So I will just assume every time I show the Plasma contract, I'm actually talking about some guy mining here, and I'll also get rid of this. We don't, just for simplification, right? So let's get started with Plasma. The Plasma operator doesn't have as much authority as every miner on other chains. It's a restricted authority. So he can mine your blocks, but if he includes a double spend here, so for example, I don't know, I've double spent a transaction and he includes that, so we collude, then anyone can come and challenge this guy. And challenging this guy is as easy as providing the 2 transactions that double spend a previous output. And of course, everyone could try to challenge my transactions, but they need to provide a proof. And the developers under you will now ask, well, the proof is probably submitting the block, and it takes a lot of capacity to validate that. No, that's why we have Merkle trees, and Merkle trees have very compact and efficient proofs. So how do I prove that transaction 1 was included in the chain? I take transaction 1, and I take all the branches of the Merkle tree until the root, and I just provide the hashes. So I hash transaction, I get a hash. I hash it with its neighbor, I get another hash. I hash that with its neighbor again, and then I get the Merkle root here. So the smart contract can, in this moment, just providing this little data, basically be sure that this transaction was included in the block. If it can make sure that both transactions were included and they point to the same previous output, what will happen? Oh, so this will revert the block, the plasma block, and this guy gets penalized and he loses his deposit. Bam, super secure. Let's go. So we've sent 1,000 transactions, but transactions of what? Well, we sent PEF or plasma ether. Or yeah. So how does that work? First of all, Alice comes along and she's like, I want to use my Ethereum on Plasma because I want to send 1 million transactions. She deposits her Ether. In that moment, the Plasma operator, he issues a special transaction assigning that Plasma Ether to Alice, and she's ready to transact in light speed. Cool. So Plasma exit. I want to get out of Plasma. What do? Very simple as well. So there was a block on the Plasma chain which showed that I have some funds, some PEF or Plasma Ether. Let's say in this output here. So I'm Alice, and I'm just sending a proof to the Plasma contract that I have an output on this Plasma chain. Very compact proof, gets verified, and this is the wrong way. Holy shit. I receive my Ether. Wow. And I receive my Ether from the contract. Done. I exited from the contract. So here is a big problem, a security issue, and it's called data availability problem. So because the Plasma miner is not someone, is a restricted authority and you don't necessarily trust him, it doesn't also, there is no guarantee that he will give you the block data. What he can do is just mine a block with like bogus double spends, to himself like 1,000 times, creates a hash of that and submits it to the Plasma contract. And Alice has no idea what's in this block, right? And then the Plasma operator puts on a hat and sends transactions and withdraws all the money which Alice before put in the contract. And we end up with fractional reserve. So no money in the contract. When Alice later comes and wants her money, nothing there. This was Plasma. There is a couple of drawbacks with this classic model. It is the data availability problem. So at any time there is a risk for the contract to go fractional reserve. And what you need to do is basically when you notice that your Plasma operator is withholding block data, you exit. You have 7 days to exit to get your money before the Plasma operator could kind of, steal it from you. And that's an assumption about Plasma chains in general, that you can exit at any time without needing to interact with the child chain, like a state channel. So that was Plasma. And now Vitalik and Carl, they introduced Prisma Cash, which is even cooler. Prisma Cash works a little bit different. So in Prisma Cash, when you deposit, you receive a coin with a specific ID. Like, a bill of money with a specific number. That's why it's called cash. And there's a couple of rules to this. So coins cannot be split and cannot be merged. So you have 5 Ether, you have a 5 Ether Plasma coin, it stays a 5 Ether Plasma coin. Transactions, spending coins must be included at the position in the Merkle tree corresponding to your ID. So let's say I'm the 6th guy depositing into Plasma, right? I get the ID 5. That's a binary 1, 0, 1. So how do I include that? I can only include that in the Merkle tree at 1 right, 0 left, 1 right. That's where my transaction has to go. What's the advantage of that? Well, we can sort the Merkle tree. And with sorted Merkle trees, we can not only do proofs of inclusion, we can do proofs of exclusion. Woohoo! What does that mean? So that means that if I am a Prisma Cash user, I don't need to verify all the chain. Like in that classic model, Alice needs to do n, the size of the blocks, times t, times like how many blocks there are, needs to verify all the data to make sure that the chain is valid. That doesn't scale very well. With Prisma Cash, she only needs to have that specific Merkle tree branch of her coin in every block to verify that. So what can we do with that? pretty cool stuff. We can send transactions again, even more than before. And how do we do that? So Alice obviously includes a transaction at the Merkle tree in the Plasma contract. And at the same time, off-chain, she gives the proofs of history to Bob. This is all the previous transactions that happened since the deposit of the coin. And why is that cool? It's cool because the data withholding attack is not a problem that much anymore. So imagine the operator mines a bogus block again. We don't know what's inside. We only see the hash because that's what got committed to the Ethereum blockchain. And then this guy comes, puts on a hat and wants to exit coin 5. But no, coin 5 belongs to Bob. And Bob knows that because he has the transaction history, which he remembers from Alice. And he's like, no, challenge. And then that exit is slashed. It doesn't happen. So, Prisma Cash. This is wrong. Who wrote this? Anyway, this is supposed to say Plasma Cash. So, I'll just repeat one more time and then I finish, I promise. So, only coins that have been deposited can be withdrawn. That means that any attempt to steal a coin has a specific victim. And the victim has a verified history of his coin, so he can challenge that. So the operator can't like inflate UTXOs or something like that and steal from everyone. Fractional reserve is impossible. So we are more hack resistant, and this is exponentially scalable. I don't need to download every block and verify it. I just need the Merkle root of my coin ID. And this is much wow, so Plasma. Thank you. I'm not done yet. So how can I contribute to Plasma development? Join the Plasma developer call. It's every 2 weeks on Wednesday, and you can watch it and learn a lot. And this is the most important stuff. Where can I use Plasma? You can use it with Parsec Labs. That's the thing. Get a t-shirt. We're here. We're distributing flyers. You can have access to our blockchain. And we run games on Plasma because it's amazing cheap, and you can do great smart contracts on there. There's also other guys working on this. So MisaGo, BankX, Voltaire Labs, and so on. Thank you.